All right, looks like we're live. Hello and welcome to Mr. Linford's math course. This is the afternoon live stream. In the morning live stream, we reviewed section 12.3. We reviewed the exit ticket problems from 12.3, how to determine the domain of a logarithmic expression. So I figured for this afternoon session, we'd continue reviewing section 12.4, things that you would have explored in today's activity, in today's lessons. If you have any questions as we work through the problems from 12.4, feel free to let me know in the live chat that we have going on the side here. Let me know if there's any questions or comments, or if there's anything you'd like me to review additionally, or any problems you want me to go over, or if you just want me to slow down and re-explain, just let me know. I figured we'd start in section 12.4 with problem 4 from the independent practice. In this problem, we are asked to expand a logarithmic expression. By expanding a logarithmic expression, we should first identify what the argument is. Here, the argument is x over y times z. Let me write that down here. X over y times z. That's the argument. Our goal when expanding an expression is to have each of these terms in the argument, the x, the y, the z, having all of them be their own logarithmic expression. What I mean is I want a log of the argument x, a log of the argument y, a log of the argument z. I want each one of those independent of each other. So, to do that, we had several properties we learned about in today's lesson. One of those properties said, well, if you have a fraction as an argument, if you're doing a division, we call this the quotient property, you're able to separate the argument into logarithms by subtraction. Before I can get at the x, the y, or the z, before I can start moving them around, I have to get them outside of that fraction, don't I? So we're going to use the quotient property that said you can take log base 2 of x and subtract log base 2 of y times z. This was the quotient property, and it connects back to our work in integer exponents, I'll say. If you remember the division of like bases property, we had something like x to the n power divided by x to the m power was x to the n minus m power. So we said if you are dividing numbers that have the like bases, you subtract their exponents. Well, here we're dividing numbers, and remember, logarithms equal exponents, so we're just subtracting the exponents. Now, that's sort of the connection that we have here to why this property is working. If you watch in the videos, I actually go through a little more formal proving of how this property works, but it's connected to the division of like bases. Now, we have x as its own argument, but we also have y times z as an argument. I don't want y times z, I want just y and just z. I want to separate those. Well, we had another process for doing that. We said that we could take log base 2 of y and add on log base 2 of z. If you're multiplying the arguments together, you can separate them by addition, okay? So log base 2 of x times y is log 2 of y plus log y of z. Now, I'm going to do something very careful here. I'm going to put this whole expression in parentheses or brackets. The reason for this, keep in mind that I'm saying I'm subtracting log 2 of yz. Well, this is what that equals, so I'm subtracting the whole thing from it. That means I'm going to have to distribute this negative through. And so let's go ahead and do that. We end up with log 2 of x minus log 2 of y minus log 2 of z. A lot of times students forget to put these brackets around the operations or around the expression. You have to do that because, again, we're subtracting all of this, not just one term, okay? So just be careful with that. Make sure when you're substituting something in for something, like I'm substituting all this in for the log yz, go ahead and wrap it in parentheses or brackets. So this would be our final answer. We have x by itself, y by itself, and z by itself as the arguments. We could say to ourselves, can we simplify any further? Well, no, I don't know what log 2 of x is. That's just a variable. So nothing here cancels out. Sometimes it will, and you have other properties that we went over that talk about how to go about simplifying these if at all possible. But in this case, we don't need to. So everything is set for this to be our final expanded answer. Now let's take a look at another problem. This time we have the entire argument wrapped in a radical. So here our argument is the fourth root of w cubed z over x squared. Let me rewrite that, x squared. Close enough. We have the entire argument first involved in a radical. If I want to separate the y, the z, and the x, I can't do that without getting rid of the radical. That's the first thing that's got to go, because I can't move any of these terms around without first dealing with that radical sign. So, how do I do that? Well, one of the techniques is to first rewrite this argument. Instead of to the fourth root, raise this to the 1/4 power. That's the same thing. Taking the fourth root is the same thing as raising something to the 1/4 power. So, if you see that it's raised to an exponent, hopefully you're remembering the rule that we have in the video that you can take this exponent and multiply it out front. So I'm going to go ahead and do that. I'm going to take 1/4 times log base 5 of w cubed z over x squared. That was a property. I went through and I kind of tried to prove it a little bit. In the video. Hopefully those proofs make sense. If they don't, or if you're kind of lost on them, feel free to let me know. I can go over them with you. But it's not vital that you know where these things come from. It's just helpful having an idea of how the things are manipulated together. So we have 1/4 times the whole log expression. Now we can start manipulating that logarithm. Oh, but wait. It's trapped in a fraction still, right? I can't move and separate the y, the z, and the x's because they're trapped in a fraction. So I better split that fraction up. We have 1/4 times, log base 5 of the numerator, w cubed z, minus log base 5 of the denominator, x squared. So I've separated the fraction by the log of the numerator minus the log of the denominator. This is the same thing as these two expressions combined. Okay? Same exact thing here. But hopefully you're saying, wait a minute, Linford, wait a minute. Don't forget to put it in brackets or parentheses. The reason being, you're taking 1/4 times this whole thing. Well, this whole thing is this whole thing right here. So you're going to have to eventually distribute 1/4 through, and that's okay. Let's keep going, because notice that the w and the z's can also be separated. We have 1/4 times, let's take log base 5 of w cubed plus log base 5 of z minus log base 5 of x squared. Okay, we've gone through and we've now separated the w, the z, and the x. One thing that you should say to yourself now is, can we keep simplifying? Can we keep breaking this down, or I should say expanding it outward? And actually we can. We always want just the variables or the numbers by themselves in the arguments. I don't want exponents in there. Right? I don't want a w cubed, I just want a single w by itself. So, what do? Well, just like this step back here, we're going to apply it down here. Let's take that exponent of 3 and bring it out front. So I'm going to have 3 times log 5 of w plus, well, there's no exponent on z here, so I'm just going to leave that as log 5 of z, minus, oh look, the x is actually an x squared, so I can bring that out front to be a 2 log 5 of x. All that we did here is we said, okay, if there's an exponent, bring it out front, multiply it to the values out front, okay? Make it almost like a coefficient almost. So now that we did that, we could leave our answer as this, or if you wanted to, you could distribute the 1/4 through. I'm going to go ahead and do that. If I distribute the 1/4, I get 3/4 times log 5 of w plus 1/4 times log 5 of z minus, well, 2 over 4 is just a half log 5 of x here. And this would be the final answer. We can see that we have all of the terms that were originally in the argument, the w, the z, and the x. All of them are their individual arguments. They don't have exponents, right? We brought all those exponents out front, and we're good to go. We've separated them all by addition and subtraction, so we should be set. Let me know, again, if you have any questions about what's going on here. We're going to step it up just a little bit more. This problem in particular is really going to rely on our use of parentheses as well, so make sure you're feeling confident with that. And let's take a look at problem 5 from the advanced practice. Oh, and by the way, this problem right here was 6 from the independent. It was also the first exit ticket problem, okay? So taking a look here, we have log 4 of this whole entire argument. Well, that argument has an a cubed and a b, and all of that's raised to the second power, and then it has an x and a y cubed. There's an x and a y cubed. So I'm going to need to have really 4 different logarithms here. I'm going to want one for a, one for b, one for the x, and one for the y cubed. So can I first start breaking this apart? Can I separate the a, the b, the x, and the y? Well, not right away. We can't do that right away because it's still in a fraction. This is different than the previous problem. In the previous problem, we had the whole thing would have been raised to the exponent. But here we just have the numerator, right? So we just have a numerator and a denominator. This is just a fraction problem. So let's separate it as such. Let's take the log base 4 of a cubed b squared, and let's subtract, let me rewrite that here, let's subtract log 4 of xy cubed. All we've done is subtracted the numerator from the denominator. Now we can go ahead and start trying to break each of these arguments apart. Now the first thing is, can I break apart the a and the b? Well, no, because they're still trapped inside with this exponent of 2. So we're going to have to pull the 2 outside. We're going to have to move it right out front here. So I'm going to move the 2 out front, and we're left with log 4 of a cubed and b. There, now it's no longer trapped inside of the exponent. Now we've got them by themselves. Minus, can I separate the x and the y? Yes, we actually can. They're not trapped in any exponent, right? The only exponent is on y, but those are 2 separate terms. So let's take log 4 of x and log 4 of y cubed. So we've split those up. When we split them up based on multiplication, we can add them together. But keep in mind, we're subtracting this whole thing. So I better put all of this in brackets or parentheses. I better section that off because I'm subtracting the whole thing. So when I split that log 4 of xy cubed up, I need to subtract both of those values. Let's keep going here. We have a 2, a log 4 of, well, I can split up the a cubed from log 4 of the b, but I have to put these in brackets as well because it's 2 times this entire thing. Well, that entire thing is right here in parentheses. So I'm going to have to distribute that 2 through. Let's go ahead and let's distribute this negative through. Just because I'm running out of space, I'm going to have to move on to the next line here. Log 4 of x minus log 4 of y cubed. Yeah, let's go ahead and just distribute that 2 through. I have 2 times, you know what, let me try to see if I can get any extra space here. 2 times log 4 of a cubed plus 2 times log 4 of b. Oh my gosh, my handwriting is terrible. Log 4 of b. And then let's have minus log 4 of x minus log 4 of y cubed. Hey, there it fit. Okay, so all I did was I just distributed the 2 through to each thing here. No big deal. We could ask ourselves now, can you keep simplifying, by the way? Are the arguments able to be expanded anymore? Well, hopefully you're saying yes because there's exponents on them. I don't want the argument of a cubed or y cubed. I want just a, and I want just y. So what I'm going to do is I'm going to bring that exponent out front and multiply it. So instead of having 2 log 4, I have a 6 log 4 of a. And then I have a 2 log 4 of b. Well, that doesn't simplify anymore. Minus log 4 of x. Again, that doesn't break down. But here I can bring the 3 out front. So I'm left with a 3 log 4 of y. And this would be the final answer. Gone through, and what we've done is essentially separated out the fraction, and we were careful with parentheses here. Please make sure that you're seeing why these parentheses are working. If you have any questions, please let me know. If any part of this problem didn't make sense to you, let me know. We got a live check going on to the side here. I'm happy to review whatever you need me to, okay? And of course, if there's other problems that you'd like me to go over, please let me know. But all that we've done is we separated the fraction from the numerator and the denominator, and then we worked to piece each thing apart. In the numerator, we had to deal with that the squared value first. We couldn't get at the a or the b. We had to deal with the squared value first. In the denominator, we could separate each one individually, but then we had to deal with their individual exponent on the y and the individual exponent on the a. Hopefully, again, they're just making sense to you. I'm not seeing any comments in the live chat, so I'm hoping it's going well for people and it's making sense. Let's go ahead and let's try now to actually do the reverse and condense logarithmic expressions. I got these 2 problems here. They're the same on the independent and the advanced practice. Problems 2 and problem 4. What I'd like us to do is use these properties that we just did to expand things out to work in reverse, to see what we might have started with, to condense everything down into a single logarithmic expression. That's the big goal when you're condensing. When you're expanding, you want a logarithmic expression for each of the terms in the argument. When you're condensing, you want just a single logarithmic expression left over. So let's go ahead and try to answer that. The first thing we should notice is there are numbers out front here of the logarithm. I've gone and I've multiplied 2 to log 3 of x and a 3 to log 3 of y. Hopefully you're saying to yourself, well, that came to us. Anytime we moved a number out front of a logarithm, that was because it was an exponent on the argument. So we can go ahead and rewrite this to be log 3 of x squared minus log 3 of y cubed, and then just a log 3 of z by itself. What we're doing here is we're saying we know that when we have exponents, we move them out front. So if I saw something out front, I can always move it back. And these two lines here, exactly the same thing. There's no difference between either of these two, okay? They just look a little different, but they represent the same thing. Let's keep going now. We have logarithms separated by addition and subtraction. Well, I remember when we were subtracting, we were dividing the arguments. So we must have had log 3 of x squared. Let me try to rewrite that a little nicer. X squared, close enough, divided by y cubed. When we were subtracting logarithms, we must have been dividing their arguments. And now we're still adding on a log 3 of z. But keep in mind, when we were adding logarithms, that was the same as multiplying the arguments together. So that's a log 3 of x squared times z over y cubed. Okay? All I've done is I've multiplied in the z with the x squared to get x squared times z, and that's over y cubed. Anytime you're subtracting a logarithm, its argument goes in the denominator. Anytime you're adding an argument, anytime you're adding a logarithm, its argument goes in the numerator. Okay, so addition goes to the numerator, subtraction goes to the denominator. And that would be our final answer. We have it now all in one logarithmic expression. Let's try the next problem. This one, going to be a little different. One, we're dealing with fraction values and whole numbers. Well, nothing different with that. All you got to do is the same process as before. So let's go ahead and take log of a plus 1, and let's raise that to the 1/4 power. And then I'm going to do the same thing for b to make it b squared, and the same thing for c to make it c to the 4th power. So remind yourself, of course, that anything to the 1/4 power, like right here for a plus 1, that's the same thing as the 4th root of a. You don't have to have that written, but it's good to remind yourself of that. Let's go ahead now and start building our fraction, because I see we have subtractions going on here. So let's start piecing these things together. If I'm subtracting, that means I must have divided the arguments. So I have log, my stylus is dying out on me. I have log of, well, that's a plus 1 to the 4th power. I'm just going to write that as the 4th root. Hope that's okay for you. Divided by b squared. Okay? When we're subtracting, the negative or the subtracted value goes into the denominator, and then we're also subtracting a log of c4. Well, that means we're going to have log the 4th root of a plus 1 all over b squared c to the 4th. Again, because I'm subtracting, I know that this goes into the denominator. It's part of my division, okay? And this would be our final answer yet again. All we're seeing each time is that we are just undoing the rules that we expected to do, right? We did things very orderly. We would maybe move the fractions, right? So we'd subtract the numerator and the denominator. Then we would start probably pulling them apart by the product property. Then we might apply all their exponents through. That's what we would do when we would want to expand things, but now that we're condensing, we're doing it all in reverse. We're putting the exponents back, we're rebuilding the fraction, and we end up with a single logarithmic expression. Let's go ahead and take a look at the second problem from the exit ticket. Again, this problem is asking us to go ahead and really try to simplify this or condense it down. So the first thing we should do is take care of these numbers out front, because I can't piece things back together when there's numbers out front. So that's just going to be log base b of x minus log base b of x cubed, because I move the exponent, or I move the number 3 back into the exponent of the argument. And then here we're going to have log b of x to the 4th, because we just moved that back into the exponent. Now, since they're all just standard logarithms, I can go ahead and rebuild the fraction that I was working with. We have subtraction here, and when we're subtracting logarithms, that meant we were dividing the arguments. So that's log base b of x over x cubed. And then I'm adding on a log base b of x to the fourth, okay? Now, since I'm adding a logarithm, that means I must have been multiplying their arguments. So log base b of x to the fifth over x cubed. You could actually go ahead and simplify this even more. We can simplify inside the argument to get x squared. So we end up with log base b of x squared as our final answer. This is the fully condensed version, okay? Again, it's just relying on my knowledge of these properties and feeling comfortable with it. I don't see any comments in the live chat or any questions, so I'm assuming we're doing okay. If you do have any questions, please let me know. You can always contact me via email. My email, as you know, is klinford, that's KLINFORD, at wccnet.edu. Let me know if you have any questions or comments or things you'd like me to go over more or re-explain. And until next time, take care.